fringe width. So this O is the central part of the center of the screen. Center means it is the line. So one line will be drawn from the midpoint of this line joining these two slits. It touches the screen at point O. So that is the center of the screen we call. So for this point O, path difference S1O and S2O is 0. The difference is 0. Paths are equal. So naturally at O we will get bright. The intensity will be maximum. So in case of Young's double slit experiment or similar to this one, the central fringe is always bright. If the experiment is done with the help of sunlight, then also for all the light, this is the center. So here it will be maximum for all, violet, indigo, blue, green, orange and red, all. So that's why here will be the white and rest all will be the colored. In that case, dark will not be obtained. But here, if we are using monochromatic source, then we will get dark and bright. So this is monochromatic source we are considering. So monochromatic coherent source. S1 and S2 are suppose we have taken the special arrangement, maybe Fresnel's biprism or by Lloyd's mirror, whatever, many arrangements are there. So by that, suppose we have taken one sodium lamp and then that is coherent source is produced by using general common is the Fresnel's biprism. But this is not in our syllabus, so we will not do into discuss. Okay. So for any point P which is at a distance x from the center, the path difference is what? Any point P situated at a distance x from the center of the screen. What will be the path difference? This delta will be S2P minus S1P. Now, if we draw a normal from this S1, normal we have drawn from S1 on M. Now what is there? S1P and MP are equal. No? If we draw the normal here, so this two will be equal. So what is the path difference? That will become equal to S2M Is it clear? So S1P and MP both are same, equal. No, same is that. So S1O and S2O are equal. This is perpendicular to each other. Okay. So we are interested to find this S2M. Now for that, suppose we are taking angle. This one is angle phi. Okay. So how much it will come? This is 90 degree. So sin phi will be, sin phi is S2M by S1 S2. So this delta is d sin phi. Clear? You can write in triangle S1, S2, M. Okay, this triangle we have taken. So this S2M, which is the path difference, is d sine. Now, as this point P is very close to O, very close to O. So this phi is very small. And therefore, this sine phi will be approximately 5 only. Or sine phi approximately, we can say 10 phi also, no problem. Or without this one, we will substitute afterward this one. We can write this one 10 phi will be equal to x over d. Of course, we'll use this one also. Sine phi will be approximately 5. So in that case, what will be? So from these two, what we are getting? This delta will be dx over d. Or this x will be d by d into delta. So both relation frequently we use while solving the numerical. Any confusion? Now, at P we will get bright. When? If the path difference is L lambda. That is the condition. So at P, intensity will be maximum. If this delta is L lambda. X d by d is L lambda. Your delta is this much only. That means this x is d by d L lambda. Yes.
Yes, sir.
Today Anmol is not visible. Absent.
No, sir, I'm here only.
So this X is d by d n lambda. That is the general condition for bright fringe. And what is the value of this n? This n is 0, 1, 2, 3, like that. So for x equal to 0, that is at the center, that we call central bright. So for central bright, we say this x is 0. Now, where will be the first bright? For first bright, it can be both sides, this side as well as this side also bright will be there, not only one side. So for first bright, what will be this x1 may be, we can say plus minus d by d lambda. This n is 1 for first bright. That means at this much distance above central fringe, we will get again bright. Below this, we will get again bright. This side also, that side also. Both the side we will get bright. Path difference may be this side S2P minus S1P, or when it coming this side, S1P minus S2P will be there. So both sides we can consider.
Sir, don't rub, sir. The board is not clear, sir.
Now,
No, sir.
okay.
Yes, sir.
So this is for first bright. Similarly, for second bright, this x2 will be plus minus d by d2 lambda, or twice d by d lambda, you can say. Here this n will be 2. Plus means above, minus means below the screen. Similarly, we can keep on counting third, fourth, like that, nth. For third, x3 plus minus 3d lambda over d, or you can do plus minus x3, no problem. And it will be both sides. This side above, that side down. For nth bright, what will be? Should we keep on continuing? So for nth bright, this xn plus minus n d lambda over d. Now, distance between two consecutive bright. You see the distance. This minus this, this minus this, this minus this, nh minus n minus 1, all are same. If you subtract this one from here, same d lambda by d. This one from here, d lambda by d. This one from this one, d lambda by d. So this distance between two consecutive bright we call fringe width for bright or fringe width of bright, whatever you may say. So fringe width for bright. This is distance between two consecutive. And this is equal to d lambda over d. Now, one thing no one asked question, how this sine phi and tan phi become equal to x by d? No one asked question. Huh? We have taken this one phi, but x by d is not that one, no? No one asked question anything. Means simply you are copying. Your brain is not with you. So if we are joining this one, this angle and this angle will be same. Then only we say tan phi will be x over d. This angle and this angle will be same. Okay, so this is fringe width for bright fringe. Now we'll find at P under what condition we will get dark. Now central dark will not be there because at center path difference is 0, so it will be bright only. That's why central fringe means bright fringe in Young's double slit experiment. Now at P intensity will be minimum, that is dark. If what is the condition? When it will be dark? If this path difference is 2n minus 1 lambda. Here we are taking 2n minus 1 because we have to start n equal to 1. N equal to 0 is not possible here. Central is only 1 and that we have got already bright. So central will be bright only. Now what was the relation for this delta? What was that? X divided D or something else? Huh? Is this correct? Capital D by small d or small d by capital D? What was that?
Small d by capital.
Small d by capital D. This all are sleeping. I don't know whether you are listening or only one is listening or two is listening. and rest all has gone somewhere else. Where are you, Anmol?
Sir, here only.
Here only. Shreyas?
Here only, sir.
Here only. Then what is the problem? No response coming. Sukhnandan, can you hear me? No. Yeah. But it's net is very. So just to inform Mohit also about that. So this x d by d will be 2n minus 1 lambda. That means so this x is d by d lambda here, okay, 2n minus 1. And here n will be from 1. 1, 2, 3 like that. 0 will not be there. So for first dark, x1 dash or plus minus x1 dash you can say, what will be? N is 1. So n1 means plus minus, where it will come? No, this one was not the condition. What was the condition? Here, what was the condition? For intensity minimum, what was the condition for minimum intensity?
2m minus 1 lambda by 2.
Then why you are not, where were you? So it will become d lambda over 2d. Here n is 1. Similarly, for second, third, we can do. For second dark, x2 dash will become plus minus 3d lambda over 2d and equal to 2. For third, five d lambda over 2d and will be 3. Similarly for nth, so for nth dark, now if we find the difference between these two, what we are getting? That is the fringe width for dark. So difference between this and this, or difference between this and this, is it same as bright or it is different? Yes. If you subtract this and this,
Same, sir.
same thing, d lambda by d only.
Yes,
So
sir.
whether it is dark or bright, fringe width will be same. So fringe width will, for dark, that is distance between two consecutive dark. So this is also same, d lambda over d. So in general, we say the fringe width is lambda d over d, whether it is dark, whether it is bright. So in general, that is for dark and bright both, the fringe width This beta is lambda d over d. So this is the relation for fringe width. Okay, we'll leave up to here. Tomorrow we shall start from this place only. Yes, anyone having any doubt, anything to ask?